Okay, 3.2 and 3.3 is part C of this note series. Simplifying with exponent laws, a learning target. To apply all exponent laws to simplify expressions. So, yeah, now we're just going to do the same sort of thing, but now we're going to simplify it to as far as we can. Toolkit, exponent laws. So hopefully we reviewed it. We're going to review it again down here. Fractional and negative exponents. We've talked about that. Hopefully you understand how to do that. Order of operations with fractions. So remember, BEDMAS applies to fractions as well. So let's quickly review the exponent laws. So remember, exponents of 1. So anything to the power of 1 is just going to be itself. So example here. Exponent of 0. So anything to the power of 0 is just going to be 1. Example, you can read that example. Product rule, when you're multiplying the same base with exponents, you're just going to add the exponents together, right? Quotient rule, when you're dividing the same base, you're going to subtract the exponents, okay? And again, notice these restrictions here. A cannot equal 0. Why does it say A cannot equal 0? Well, in this case, the denominator can never really be 0. And also, well, these rules don't apply when it's 0 as well. So like 0 to the power of 5 is just going to give you, 0. So it's not going to really work. Okay, power rules, continuing. So it's hard to see on here. I wonder if I can zoom in on my camera. Not really, unless I manually push it down. So the focus is really bad now, so that doesn't really help. But you can see on the notes I'll upload, hopefully be more clear. Quotient rule is basically, you're just going to subtract them. So the same base, you can subtract the top exponent with the bottom one, right? So the example there. We got our power rules here. So exponent to an exponent, you're going to multiply them, right? So if you have it outside the brackets, you're going to multiply these two exponents. And if you have an exponent on the outside, you got two different bases here, A and B. This gets distributed to both. So it goes onto the A and it goes onto the B. So you can look at the example. I'm going over this really quick because we just went over this stuff. Yeah, and the fraction, same thing. The exponent goes to the top, the numerator, and it also goes to the bottom at the denominator. Negative exponents. Remember the negative exponents to make it positive. And this one's really unclear. Say there's a negative 5 here. To make it positive, you flip it. You get the reciprocal, right? So flip it around. Here, if you have a fraction, a base over another base, and you have a negative exponent, flip them around. B at the top now, A at the bottom. It doesn't really say that. I think my ink was running out. But that will just give you a positive exponent, right? So we went over that as well. And rational exponents. So remember, this is just basically using going from a radical. So radical is basically the thing with the little check mark sign here, to an exponent form. So here there's an invisible 2, right? The invisible 2 is the root, and we can move it. So I'll just write it really 1 over 2. So like that, and this is the exponent, right? So there's an invisible 1 here. So and there's a visible 2 here. So this one was probably not the best example. So the 2 goes underneath. So you can see, I don't know, we'll do another example here, 3 and 4, right? So something like that. I can even put this to the power of 2, right? And then this is the same thing as 4 to the exponent 2 over 3. Okay, hopefully that's kind of, so this is the power, this is the root, and this is the radical, or I guess the whole thing is a radical. This is a radicand inside. Yeah. Okay, hopefully that was a quick review, and you can look over that on your own time or ask me questions on Microsoft Teams if you need help. Okay, let's go over this pretty quick here. So simplify writing as a single power. Okay, so it doesn't seem like anything's new here. We kind of went over these as well, but we'll do it again. So 6 to the power of 2 and 6 to the power of negative 6. So what you're going to do here is you're going to just add them, right? So they're multiplying, so you can add the exponents. So 6, 2, and negative 6. You get 6 to the negative 4. And then finally, there's a negative exponent, so you're going to put it to the bottom, which equals 1 over 6 to the power of 4. And we'll just leave it there. You can obviously evaluate that as well. if you want 6 times 6 times 6 times 6, which is, I don't know, I can't do that one in my head. Okay, next one here, again multiplying, so we're going to add the exponents, x to the negative 4, and we got plus 7, so we got negative 4 plus 7, x to the third. So this one's going pretty quick. So remember, when you're dividing, you're subtracting the exponent. So here we got m is at 7, I think. Yeah, 7. And it's minus, so it's because you're dividing minus negative 2. Negative and negative is positive, so we get m to the power of 9. Okay. Okay, here's a decimal one here. So let's try that. You're dividing them, but the base is the same. So when you're dividing, you're just going to subtract, right? So power of 3 minus 4, so equals 0.4 to the power of negative 1. Okay. And remember, you're just going to flip it to find the positive exponent, right? Okay. Okay, over here we got e, so it's n to the power of 2 to the power of negative 4. So this is a power to the power, so I guess that's the power rule, or yeah, power rule I think it's called. So let's do this, and 2 times negative 4 is negative 8. And finally, just flip that around to get the positive exponent. All right, so that one's done. Next page. Okay, here it looks harder, so when you see this, but now you're just gonna take it one step at a time. So let's do this. So first off, you got power to a power. So you got, I'm gonna try writing kind of small, but not too small, so you guys can still see. So keep the inside the same. So negative 4 to 7, and negative 3 times 2 is negative 6. So negative 6. And divided by, let's do the other side too. You got negative 4 over 7. And on the outside, you got negative 20. Okay. So now what you're going to do is you got the same base, and you're dividing. So remember, you can just subtract then. You can subtract the exponents. So equals negative 4 over 7. And negative 6 minus 20, which gives you positive, because negative times negative. Oh yeah, so my computer got full because the videos were long. So anyways, we're back. So this was the answer, so to the power of 14. Let's do the next example. We got the same base, so whenever it's the same base, it's pretty straightforward. Negative 3, you know, is power to the power. We got to do that rule to multiply. So at the top, we got 2.3. Negative 3 times negative 5 is negative 15 over 2.3 to the power of 5. And now we're dividing, so we're going to subtract the exponents, right? So we'll get negative 0.3, negative 15 minus 5, which is going to give you 2.3 to the power of negative 20. Okay. Good. All right. So next question here, we got oh wait, there's an error here. Sorry. Negative 3 times negative 5 is not negative 15, it's positive 15. So positive 15, 15 minus 5 is 10. So this one should be 10. So 2.3 to the power of 10. All right, so here, this kind of looks like a jumbled mess, but let's do the numerator, the top section first, and then we'll tackle the bottom. So you're multiplying the same base, so we can add the exponent. So when you're adding fractions, you just add the top, right? You don't worry about the bottom part. So the top is going to be 5 plus 1, which is 6, and the denominator you just leave as 4. Okay, and then we got 8 to the power of 3/4. Okay, so luckily the fractions have the same base, so we can just subtract them now, right? So 6 minus 3 gives you 3, so it's going to be 8 to the power of 3/4. Okay. All right. Good. So let's keep going. Okay, here some of the questions get a little bit trickier. I think the bottom ones, is this the last page? Oh, there's another page here. So let's just start this off. Again, when you're multiplying the same bases like this, what we're gonna do is just add the exponents. So x, so there's 4 here, 2, so 4 plus 2 is 6. And then y is the next base, negative 2 plus 3 is gonna give you just 1, which we could just leave as y, right? So there we go. Then we got part 2, or part B. So this power to a power. So this 1/3 is going to go to the 27. It's going to go to the 27. It's going to go to the x. It's going to go to the 9, right? So remember 1/3 of 27, like the exponent, to make it into a radical, you put the 3 on the outside, which we went over a few times, like this. Okay, and then there's a visible 1 here. And then let's do the same thing to the x. So x is to the power of 6. So we can just divide it by the third here. So 6 multiplied by 1/3. So 6 times 1 is 6 over 3. So 6 over 3 is just 2, right? So, and then we got our y. So y, 9 times 1 is 9. 9 over 3 is 3. Okay. So now the next step here. I know I skipped a few steps there. Okay, I'll do on the future examples. I'll do all the steps, and I'll also upload all the steps as well. So now, what number multiplied by itself 3 times gives you 27? So you should know that's 3, and these ones are pretty much set how they are. So there we go. Okay, so let's go on to part C. So this one has a few things. It might be kind of tricky to do this one. So first thing you want to do whenever you see questions like this, you want to simplify it as much as you can before you start playing around with the exponents. So you know that 6 and 4, so what's the greatest common factor here? So the biggest number that goes into 6 and 14, sorry, is going to be 2, right? So 6 divided by 2 is 3. Yeah. And then you also have your 14 divided by 2 is going to give you 7. Okay. And then from here, what we can do is, now what we can do is we can start simplifying the, the variables here, like a and b. So a, 4 on top, and then on the bottom is negative 2. So remember, you can subtract the exponent. So 4 minus minus 2 will give you 4 plus 2, which is going to give you 6. So you can put, whenever you have the positives, you can put it at the top. And here we got b negative 3 minus, because we're dividing that rule, so b to negative 3 minus 2. So negative 3 minus 2 gives you negative 5. So negative 5, you can, well, we'll put it up here for now, and I'll show you. I'm going to move it to the bottom in a second. Okay. And then this whole thing is still to the power of negative 2. So when you have a negative exponent, how do you make it positive? You can flip it. So I can just put this down to the bottom. So if I write it like this, and this is positive, so I'm going to keep it at the top. Okay, so instead of putting here, I could put b at the bottom and 5. So now it's a positive 5, right? So that's why I'm doing that there. And then this is to negative 2. Yeah. Okay, what else can we do? We can flip this around as well. So why don't we, oh, it's still recording. Okay. Flip this around the other side to make this a positive exponent. So this is also equal 7 on top. So, and then you got b to the power of 5, and then 3, 8, 6, all to the power of 2. Okay, so now finally, now I'm gonna actually bomb the exponent inside. So 7 squared is 49. b 5 times 2 is 10. And then to the bottom, 3 times 3 is 9. And then a is 6, so 6 times 2 is 12, so 8 over 12. Okay, oops, I'll move it up so you can kind of see what I did here. Part D. There's D and E. Okay, maybe we'll just do D together, and then E. I'll write out the steps, and then you can take a look at E when you have time. So first step here, again, before you even do anything, simplify as much as you can. 50 and 2. Just divide 50 by 2 here, so we can get rid of that. So you got 25 now. And we are M2, so 2 minus 4 will give you 2 minus 4 is negative 2. So maybe I'll write at the top for now. And let's do the n. So 4 minus 2 will give you n to the power of 2. And then have this thing over a half. Remember what I said? You can put the m at the bottom now because it's negative. So you can write down, so for example, 25 n squared over this whole thing over m squared 1 over 2. Okay, now let's put 1 over 2 inside. So remember 1 over 2 to make this, you make it into a radical. So it goes like this, right? Because the 2 goes on to the outside. There's a visible 1 here. Move this up. Okay. Okay, 2 times 1. So whenever you're just multiplying it, right? So when you're multiplying fractions, you just do the top multiplied together. So 2 times 1 is 2. 1 times 2 is 2. So it's 2 over 2, which is just, why did I put this in a, it's okay. So it's just going to be n. Okay, and then the bottom, you do the same thing. So this is going to be m, right? Just like that. And finally, square root of 25 is 5. And this is just n and m. Okay.